Computer Graphics and User Interface. Computer Graphic User Interface. GUI. ALPHA. BIOS Trolley. Good.
Computer graphics and user
Interface.
output menu. It has been selected and it is now time to narrow the engine. This has been completed by Smitty by means of searching far and wide through the UAPB library.
Logic programming is a type of programming paradigm which is largely based on formal logic. Any program written in a logic programming language is a set of sentences in logical form, expressing facts and rules about some problem domain.
Welcome to the future. The future is now.
As in any programming language, the logic programming language selected for artificial intelligence depends solely upon user preference. AI programs have been written in just about every language ever created. The most common seem to be Lisp, Prolog, C and C++, recently Java, and even more recently, Python. IML meaning Artificial Intelligence Markup Language is an XML dialect for use with ALICE and is type Katurbits. It was the first language developed for artificial intelligence. Linked lists are one of Lisp language's major data structures, and Lisp source code is itself made up of lists. Logic programming languages declare statements that express facts and rules attributing an object. This is quite a contrast in comparison to procedural-based programming languages which are focused upon the procedures for producing the object. Logical programming languages are referred to as logical programming languages or declarative languages. Languages that use these sorts of semantics, propositions, and symbolic logic include Prolog, Answer Set Programming ASP, and Datalog. All such languages express propositions, express relationships between propositions, and possess the goal of allowing formally stated propositions to be checked for validity. This symbolic logic is called first-order predicate calculus or predicate calculus. Prolog is sometimes called a declarative language or a rule-based language because its programs consist of a list of facts and rules. Prolog is used widely for artificial intelligence applications, particularly expert systems. A rules body consists of calls to predicates, which are called the rules goals. The built-in predicate, to meaning a duality operator with name, denotes conjunction of goals, and to denotes disjunction. Conjunctions and disjunctions can only appear in the body, not in the head of a rule. Structures are the fundamental data types of Prolog. A structure is determined by its name, sometimes called the principal functor, and its arguments. The functor is an atom, and the arguments may be any Prolog terms, including other structures.
Welcome to the future. The future is now.
Logical programming consists of propositions which represent either constants representing an object or variables representing different objects at different times must be introduced by quantifiers. A compound term is an individual element within a mathematical relation, written in a style similar to that of mathematical notation. These terms come together forming atomic propositions. propositions are either true or false and are connected through the use of logical connectors operators. Causal form, comprised of the antecedent and consequence, is preferred to reduce redundancy. Predicate calculus is a tool which provides methods of expressing collections of propositions in order to prove, or disprove, a theorem, which is perfect for mathematicians which seek to uncover new theorems to be inferred from known theorems and axioms. If a set of propositions are detected with inconsistent results, this resolution is said to be refutation complete, which leads to the formation of the accurate theorem. The initial proposition is known as the hypothesis, and the negation of the theorem is the goal. Horn clauses named after Alfred Horn are restrictions that either have a single atomic proposition on the left side the head, or an empty left side facts headless Horn clauses. Horn clauses with left sides are termed headed Horn clauses, which are used to state relationships. Horn clauses makes resolution a real-world practice for proving theorems due to the fact that most propositions may be stated as restricted Horn clauses. Declarative languages are used for logic programming because it utilizes declarative semantics propositions in simple logic, opposed to the assignments and flow statements of imperative and functional languages, to solve a problem. Declarative semantics are not procedural whatsoever. Sorting points out the difference in procedural and non-procedural languages. In a procedural language, the sorting algorithm goes into a compiler, is interpreted, then the sequential directions of the instructions produce the sorted list. Whereas in non-procedural language, you simply describe the attributes of the sorted list and the predicate is returned true if its second parameter array is a permutation of its first parameter array, a permute. The downside of logical programming is, in the instance of sorting, the program must go through each element one by one until it has the sort complete. Less time is given in the design process for a more efficient algorithm. Prolog was developed under the collaboration effort seeking to join natural language processing and automated theorem proving. There are a number of Prolog dialects, all of which further developed for the goal of the user. Some categories include Marseille, Edinburgh, the most commonly available, and microcomputing, for example MicroProlog. Prolog statements and data are constructed from terms which may be a constant atom or integer, a variable bounded by instantiation during the resolution process, or are structure representations of propositions of predicate calculus in the general form of funct-to-parameter list. Fact statements, rule statements, and goal statements are used to make proper inferences during the process of Prolog. Search queries are called goals, and if a goal is a compound proposition, each fact structure is considered to be called a subgoal. Since the method of testing a subgoal is done via a proposition matching process, it is called matching, and also known as satisfying the subgoal. The two attempts at matching a given goal to a fact in the database are bottom-up resolution. Forward chaining the system begins with the facts and rules of the database and attempt to find a sequence of matches that lead to the goal best when the number of possible correct answers is large, and top-down resolution backwards chaining start at the goal and attempt to find a sequence of matching propositions that lead to some set of original facts in the database works well when there is a reasonably small set of candidate answers. Once the approach has been established, one must decide if the search will be a depth-first search which finds a complete sequence of propositions approved for the subgoal before working on the others, or a breadth-first search which works on all neighboring subgoals of a given goal in a parallel. Prolog also uses backtracking as a resolution mechanism by backing up in the goal to the reconsideration of a previously proven sub-goal, forming a new solution by starting the search where the previous query for the sub-goal stopped. Database search is always processed in the direction of first to last. Other basic elements of Prolog included simple arithmetic and list structures. As incredible as it is, Prolog cannot be named flawless. For efficiency, Prolog always matches in the same sequence, starting at the beginning of the database and at the left end of a given goal, and the user affects this efficiency by ordering the database statements to optimize a particular application. This is different from other logical programming languages, which allows the user to control the ordering of pattern matching during resolution, which creates a non-deterministic order, causing all matches to be attempted concurrently. Prolog also allows explicit control of backtracking, which is called generate and test once this sorted backtracking cut is implemented. In giving the user the ability to modify control flow, Prolog is deficient due to the direct detriment of allowing the program to specify how solutions are found. Instead, they simply specify how the solution should appear. The beauty in this is the easily readable and writable code, uncluttered by details defining the method of reaching a solution. Closed-world assumptions may manifest misleading results. This leads to a problem with negation, as from positive logic, one may only conclude positive logic, and therefore Horn clause is incapable of producing any negative results. Intrinsic limitations are created due to the goal of declarative languages being to avoid procedural programming, which leads to drawn-out processes due to the program not being told specifically how to carry out the search in the program, which means it is a very unhurried progression when it comes to sorting. Nevertheless, Prolog and other predicate logic languages are very resourceful tools when properly applied. In conclusion, there are a wide array of current and potential solicitations of logical programming. Some practical uses include relational database management systems, RDBMSs, which store data in the form of tables. Expert systems designed to emulate human expertise in a particular domain, and in natural language processing. Symbolic logic offers logical programming and logical programming languages. Allow logical programming to automate and simplify your life today. For the 2017 $1 bill you all. Smitty, we thank you. Peter, out.
We'll continue on the path of personalization, customization, and unique user experiences, making the online world ever more intuitive and human-like. Feel free to further discover business learning into these topics and more as they relate to computer graphics and user interface. #StartupLife. Business learning. Sit Smitty and Heather out. Smitty had to fire Rainer. Then I came in.
Rainer und Ruiz.